I'm so excited to be here and show you the ArcGIS Python API. It's a new API to the ArcGIS platform, super easy to use, and it's great for data exploration. So analysts and developers are going to love it. So let's see how you can use the ArcGIS Python API to do mapping, visualization, and analysis of crime. And as Jay said, it's a three-step process that starts with your data, goes to analysis, and then your results. And in many cases, the data that you want to use, it might be locked up in different file formats, might be embedded in web pages as tables, it might be inconsistent, it might not be geocoded, even though it has a spatial aspect to it. And I'm using similar data. It consists of about 1 million crime incidents from the city of Houston for the past 8 years, spread across 100 Excel spreadsheets. But that's not a problem. I can use Pandas, which is Python's data access and analysis library, to automate the task of fetching that data and read it in as a data frame. So looking at the raw data, you see that I need to clean it up. The number of offenses, for instance, are spread across many columns. It has many null values, and so on. So data scientists often spend more than half of their time in collecting, cleaning, and enriching their data. And Pandas can help make this painstaking process fast and efficient and repeatable. So here I'm cleaning up that data, and once it's cleaned up, that's what it looks like. It contains the date, hour, and day of week of the incident, the category of crime, the number of offenses, the beat, and an address, which brings us to geocoding. I'm using the high-performance parallelized geocoding tools that we just released at 10.5 to quickly analyze and batch geocode this data and load it up as a spatial data frame. The spatial data frame is an upcoming capability of the Python API that lets you work with spatial data as if it were a Pandas data frame. It's very powerful. We are adding geospatial operations to Pandas, as well as the ability to read and write to shapefiles and file geodatabases that I'm doing here. So let's see how you can now connect this data to your GIS. You can add and publish it as feature layers, or you can connect it to GeoAnalytics by adding it as a big data file share. Once you do that, the data sets within start showing up as items in your GIS, and these items have layers that you can use for your analysis. OK, the hard part is now over. I now want to visualize the crime layer that I had published by adding it to map widgets within the notebook. And in the map on the left, I've added this layer, and there are far too many points to make sense of. I can also use smart mapping, and here I've specified that in the map on the right, it should use the heat map renderer to show areas of high crime density. I can use the spatial data frame in combination with charting libraries like matplotlib to see patterns like what is the distribution of the crimes and how does it change by the day of the week. So we start seeing patterns such as that the number of murders increases during the weekends and the burglaries tend to go down. We can also see the distribution by the hour of the day and how it's different for each crime. But that only tells a part of the story. I want to be able to map out these crimes using the powerful analytics provided by the ArcGIS platform. And for that, I'm using the Find Hotspots tool provided by GeoAnalytics. And what's great about the Python API is that you can automate the task of finding these hotspots for each category and for all years in your data set. And you can generate these hotspots and persist them as information products in the form of web layers that you can use for your analysis and visualization. So I've done that, and I'm now ready to visualize it. And now I'm comparing the hotspots of burglaries with those of auto thefts. And I see that each crime has a different spatial distribution. Let's see what the hotspots, how they change over time. And here I'm comparing the hotspots of auto thefts over the past 3 years. And what's striking is that the hotspots are very similar across the years. The hotspots of yesterday are the hotspots of today and are likely to be the hotspots of tomorrow. And I can use this information to allocate resources and identify areas in need of intervention. And while the field of crime analysis and mapping is quite deep, and I'm just getting started here in my notebook, I'm sure you can all appreciate that there's an incredible wealth of tools available at your disposal to do an analysis like this. You can combine the data science and machine learning libraries from Python with analytics and content from the ArcGIS platform and do amazing things.